All right, why don't we get started? Let me start this. So today, as as you all know, I will be doing a kind of an extended walkthrough of how to use GitHub, going from the installation to some of the basics, and then also touching on some of the a little bit more advanced features as well. And the goal is to, for me to go at a steady pace. I'll try to put some little wait periods where people can catch up, and also just, as I was saying, maybe poll people if they get to a certain point, and then I can move on from there. So yeah, first off, just a brief outline. I'll first talk about the background and why to use GitHub, and then we'll go into the installation. I'll talk about the fundamental feature of using GitHub, which is version control, the ability to track changes for a file or a group of files, and to keep those track changes in history. Then I'll go into branching, which is a way to develop code or a set of codes in a isolated and controlled scenario. And then I'll talk about how to perform collaboration. So how to share and review the changes that you've made in your repository, your code base, and also how to maybe if you want to contribute to another author's code base, how you would grab their code, edit it, and then request for them to review those changes, such that those changes can be incorporated to the original code base. So first off, just for those of you who are not super familiar with GitHub and its functions, I like to think of GitHub in the context of the functionality and how it's similar to other software. So one of the main components, or one of the main features of GitHub is similar to what you find in Dropbox. I think many people here use Dropbox. So basically, the similarity is that it's a cloud storage space that has both the ability to have to contain those files in a private sense or a public-facing sense. So one of the strengths of GitHub and I guess Dropbox is the ability to share your code. There's also version history where you might know this kind of nice feature in Dropbox, in that if you right-click a file, there's an option to view the version history. So periodically, Dropbox saves versions of your file. Let's say it's like a Word document. If you needed to refer back to an earlier version, or if you needed to look at certain differences between your current documents, you can go back and check that out. GitHub kind of expands on this even further, as you'll see, where you can group the saved files together into specific snapshots, and there are even more powerful ways to, let's say, roll back certain pieces of code or features that you might have realized you don't need anymore. And then also the other kind of feature of GitHub that it's kind of akin to what you find in Word documents, as well as MATLAB, where I like this feature of MATLAB where you're able to load in and compare two different files. Typically, it's going to be a file, an earlier version of a file. So this is one like earlier version, and you can see more updated version, and you can, and what the functionality shows is it highlights the changes that you made from one file to the other. And GitHub, as you'll see, has a functionality like that, which I find very helpful. So that's kind of the take home here. If you need some sort of way to store primarily it's going to be code, store code, track the version history, and organize that version history in a manner that the public can see, as well as in a way that you can revert certain changes if need be, as well as a way to see those changes that you made. I think that GitHub is a good platform to adopt. Before we go into the installation and just the first use cases, I just want to talk a little about the terminology. So I talked a little bit about, I mentioned version control. What is it exactly? So and this is kind of a merging, I guess, paraphrasing of what is like the official definition. I'm trying to make it a little bit more digestible for the general kind of population. So version control is the task of keeping a set of documents, at least in our case, consisting of many versions, well organized, and those changes that you've made to those files are tracked in history. GitHub is a web and GUI-based software that basically enables this such version control, and those files and those changes, those track changes, are stored online in the cloud. That's the kind of web part of it, similar to how GitHub, or similar to how Dropbox has its cloud storage, as well as the web interface. And again, it's for these documents and track changes. You might be wondering, what is the difference between GitHub and Git? You might have heard Git as well. So Git is the underlying C programming language, shell-based programs that are essentially the guts underlying GitHub that allow for the version control. So kind of analogy here is that Git is to GitHub as Python script to a Python GUI. It's basically the again the code underlying the GUI that allows for the functionality. For the most part, I'll be focusing on GitHub in this talk. You can interact with Git directly using a command line, or like a command prompt sort of thing. It's called git bash. I guess the thing that I do kind of want to highlight is that GitHub is a good way to get started in using like such version control. I think that ultimately one should, once you're familiar, go more towards the command prompt platform, because it's much more flexible and powerful. There are certain things that actually that I've been learning, because there are some more advanced features that I was learning to prepare for this talk that GitHub is kind of cumbersome, but for now I wouldn't worry about that too much. So repository is an important terminology, also short for short as a repo. It is a collection of a single project's files and folders that is tracked and archived using Git. So basically, the size and the contents of a repository repo is entirely up to the user or the creator, right? But it benefits the other users of that repo as well as the author to organize it in such a way and to make sure that the files in that repository achieve a certain goal. So one example of this is, for me, I have a repository for pre-processing 2-photon calcium imaging data. So all of that is related, right? It's from taking the raw imaging data from coming off the microscopes and generating activity time traces for each cell that then can be pumped into visualization software down the line. And so I have a separate repository for the post-processing visualization codes. Another important word is commit, and it is both a verb and a noun. So when I make a commit, it is to take a snapshot of the tracked files at the certain exact time point. So it is, so you're going through the process of using GitHub and version control, you will make multiple commits. Like if you're developing consistently, you'll be making multiple commits, multiple save snapshots of the files and their contents. And so this is kind of akin to just like in a Word document, just clicking the save button. But instead of saving the contents, just the contents within that Word document, here in GitHub, a commit is a little bit more expansive. It's saving the contents of all the files that you're wanting to track. And then once you've made a commit, then the resulting snapshot is the noun. So yeah, the snapshot or version of the tracked files and contents at a particular time. Okay, so with that, I think this is a good time to transition to me showing you how to use the software. So everyone who wants to follow along, you can go to this link. I also posted it in Slack, so it's here. So go ahead and install it if you have not. So you can simply just open it up. And then for Windows, you can click this button. And then I guess for Mac, you can follow these instructions. So I'm not super familiar with Mac. But the nice thing about this installation process is that it's pretty straightforward. I think it's just a couple of clicks. I won't go through that because I think it's pretty simple. So I think if one of you who are installing it, just raise your hand or just like speak out loud because I can't see everybody on the list. Just let me know when you've successfully installed, and it should look something like this when it's installed. And I can also take some questions about my presentation as well. I think, can everyone see? So I guess everyone was following along with the PowerPoint, but it should be showing like my full desktop as well.
I don't know if anybody responded. I can see the PowerPoints over your desktop right now.
Okay, great. Sounds good. So how this is going to work is, let's see. At the beginning, I'm going to be doing it through this. I'm remoting into my laptop. I'm going to show you how to create a repository for yourself and do some of the basic track changes here. But the reason why I have this laptop as well as my main computer is because I want to show you how to do collaboration. And so I'm logged into a different account on this laptop. Is the installation pretty straightforward?
Yeah.
It's just like all right, so you do have to make an account. I forgot about that. Hopefully that's pretty straightforward.
Are you going to create a tutorial repository?
No, so we're just gonna do, let's see, create a new repository on your hard drive. So don't go into that yet, but are you on this page right now?
No, I already created a new repository on my hard drive.
You're jumping ahead, but that's fine. I appreciate the enthusiasm.
I'm where you are, Charles.
Okay, great. Okay, so I think I'll just go ahead because it shouldn't be that much more difficult once you get to here. So what we're gonna do is just make a blank repository that you can play around with. So you would do this, you click this, create a repository name. I'm just gonna say NAPE computing seminar, and you can put a description if you want. You can always just change the description later on. For now, I'm not going to put a git ignore. That's just a file that you can specify certain files that you don't want to track. And then license, you don't really need to specify either, at least for this test. So I'm going to say create repository, and it's going to look like this. So let me explain this window a little bit. So here, this is showing you the current repository you are in. So if I click this, I deleted all my other repositories, but let's see, I had to make a new one as well. Well, we can do that later. So if you have more repositories that are on your local computer, that'll be here. Now, you might have other repositories in the cloud that are associated with your account, but that won't show up here until you click this button, which I'll talk about later. What's that?
I did the desktop.
Did the desktop.
I done.
Okay, but so you're here.
Yeah.
I'm talking to Alex, who's sitting across from me. Okay, so and then here, this is called the staging area, where if you make changes to your files, they will show up here. And then this area is for committing. So once you have made the changes that you want, and they're ready to be saved as a snapshot, then you want to click this button here. One thing that I kind of want to go back to and just elaborate on is you might be wondering, how often should I be committing? And it is very flexible. You can make a commit whenever you want. But the best practice is to make commits as frequently as possible, such that each commit has its own goal, like unique singular goal. And that's important because you don't want to have a huge commit where you have edited so many different files and those edits have multiple functionality. Because let's say that one of those snippets of code, one of those functionalities you want to revert. You find that there's a bug there, or you just want to get rid of that functionality. If that singular feature or that function has been embedded in that huge commit, you won't be able to revert that single change easily. So other thing that I want to show here is what this is referring to. So this GitHub kind of scenario here is just a GUI, but it's referring to a physical location on your computer. So what you can do, and you can already see it when I'm mousing over the repository, because we had associated, you could have typed in the specific path where you wanted this repository to be located in. You can click this show and explore, and you can see that this repository that this GUI is pointing to is physically here in your hard drive. And so now the next step that we want to do is to actually start to make some changes, right? So let's first just make a text document. You can, if you wanted, you can make a Python script as well, or any other coding script. I think showing just like a text document works fine. It also illustrates how flexible GitHub can be. So I'm just going to make this as a test file. And when I make it and I go back to my GitHub, you can see now in the staging area that GitHub knows that you made some changes to that folder. Oops. Go back to yeah. So what you could do is your first commit could be like, hey, I created, and you can add some description. Here, this is pretty self-explanatory, but if you wanted to talk about specifically what you did in the code, you can add that there, just to help you remember what it was, or help other people also figure out what you did there. So I did my commit, right? And now that specific snapshot of that file and everything that is contained in this directory have been saved. And so where can you find those changes? You can click this history tab, and you can see that in this specific commit that I made, I created this test file. So then the next thing that we might want to do is make some changes to that file. So let's go back here. Maybe what we also want to do is put a new file in there. Let's just do this. I'm going to try test Python. So now this is a Python script, and maybe I want to edit this a little bit. Let's see. Hello world. And then, and we'll just leave this one blank, just to show you that it's going to track both this added file as well as the changes that we made in this text file. Now, the crucial thing here is that in our staging area, we can see the changes that were made in our repository relative to the previous commit. So you can see that the only thing that changed that it's showing for this test file is that I simply just added this text, and then this plus sign is showing that I added this particular file. And then here, what you can do is say change contents text file. And then once I'm satisfied, I would click commit to main. And then now we have this additional snapshot. So one thing to note here is that all the changes that we made here are contained locally on this computer. We have not yet uploaded this to the cloud. So nobody other people online can't see what we've any of these changes that we've made. So in order to do that, what we need to do is publish this repository. So I guess you can either click either of these buttons. Just gonna click this, and then you can uncheck this button to make it public, which means that people can see it and also make copies of this repository. If you want to just have GitHub to be able to track your own code without wanting to share it, then you would have this checked. So now, what should happen is that if I go to my GitHub account, now we have this repository, right, that we made. And this is akin to, again, like in Dropbox, the online facing part of Dropbox, where it has all the files that contained in your repository or your Dropbox folder, as well as the history of the changes that you've made, and the ability for people to download certain files. I think you can do that here. You do right-click, save link as, I believe. Or if you wanted to download the whole repository, you can do code. You can download a zip, or which I'll get into. You can clone this repository, which is basically you can make a copy of this repository that GitHub can track as well, and you can make changes to those to that repository, changes to the code, and that's your own version of that code. And it won't change any of the code from the original owner's repository. I think that's important. Okay, so I think that's where I wanted to stop for just kind of the basic track changes, basic functionality of version control for GitHub. And I think this is a good place, good starting point for people who haven't used GitHub this is the main take home, in that you can use GitHub and this platform again to be able to upload your files onto the cloud so that they're saved, and that you can make these commits to group certain changes of a certain theme, and to save those changes in those snapshots and have a very organized history of them that you can always go back to. Which actually leads me to one more thing. If you wanted to revert those changes, you can right-click and then click revert changes and commit. So maybe I'll just do that quickly. And so now you can see that this new commit says I deleted these and then removed that file. So I think right now, if I go to that folder, yeah, so it's just this now, that's empty. And the good thing is that even that revert is in the history, so you could even undo the revert. Okay, so this might be a good stopping point for people maybe to catch up or have any questions. Okay, so we can move on to a, I guess, a conceptual understanding of how GitHub and the storage spaces are kind of structured. So here I'm showing you the states and locations in which your files reside in the whole GitHub architecture, as well as the actions that you take to move your files into the different states. And hopefully this will get a little bit more clear once I explain a little bit more. So we already know that we're already familiar with the working directory, which is just simply that folder that we were working in. And you saw us me do a commit, and hopefully you're following along. So I'll explain a little bit more about these other states. So up here, this is all happening in the local repository on here, Alice's computer. And then there's also the remote instance of that repository, which is akin to, again, similar to the Dropbox like online cloud, where the important thing is that immediate changes that you make in your local repository are not immediately reflected in the remote cloud repository. You need to basically synchronize the files. But before going straight into that, we saw that we can make some changes in your working directory, and those changes you saw are automatically logged and visualized in that staging area, which is here, right? So GitHub automatically does the tracking of taking those files that got changed and putting it into that staging area or index. Actually, I should go advance this. So index or staging area. In the Git command line, this actually has to be done manually using the command git add. But it's convenient that you don't have to do that in GitHub. Now, and then you are familiar with the action of committing, which is, again, taking the snapshot of the files at that specific time. And that snapshot and, I guess, the metadata information are saved in a .git folder which you might have noticed. In here, it's usually invisible because you don't have to interact with it, but that's where all that organization is contained in. So now going more into the big picture, right, about synchronizing. So in order to synchronize the local repositories files to the cloud, you need to do what's called a push. And I'll show you in the GUI how to do that in a second. It's a simple click, and it'll synchronize, make the remote repository, the cloud repository, consistent. Clone here is, I briefly mentioned, it's the action of copying a cloud-based repository and just like making a copy that you can work on. Pull here is similar but a little bit different in that pull happens when you've already cloned the repository. It's basically if there are new commits that other people have made on the cloud that your local repository doesn't have. It's the action of bringing those into the local repository. I should have gone through this.
Hey, Charles.
Yeah.
So when you pull from GitHub, does it integrate with the changes you've already made in your local working directory, or is it just gonna like basically clone from scratch and then erase any of the changes that you've made?
That's a good question. I haven't encountered this too much, but I mean, probably the reason why you ask is it will happen. I think if you do the pull in GitHub, the desktop like GUI, likely there will be like a message that says, hey, if there's conflicts. If there's no conflicts, then it'll just like pull everything and everything will be fine. If there are conflicts, there will be a message that pops up that's saying, hey, your current files conflict with the ones that you're trying to synchronize. You need to resolve it. And it'll give you the option of opening the files up into like an editor, and you'll basically see there'll be a snippet, the section of code where there's a conflict. It'll show you the code that you're trying to sync, and then there'll be like a division where below that there'll be the changes that are currently on your repository, and then you simply need to edit it such that you either incorporate the changes that are coming from the remote repository, or you resolve it in some way. I will show you how that kind of looks like, that act of integrating and resolving those conflicts. That's going to be part of the collaboration part.
And then one more quick question. So when you do that poll and you've made those changes in order to integrate it with what you already have in your repository, is that also saved in your history? So you have like your own personal history in addition to the history of the like greater repository.
Yeah.
Okay. Great.
I think
Thank you.
Yeah, we could try testing that out too. And I think a good practice is just to do the poll every time you kind of start your coding session. And so, yeah, you can, that's just like your kind of framework, right? But if you're working in a team, there's a whole nother, I guess, branch to, or not branch, but another aspect to this whole architecture where maybe your collaborator is also doing kind of the same thing. One other thing is this action fetch, which is part of the poll action. Fetch is basically taking the updates from the remote repository, but not necessarily integrating it into your code base, is what I understand. Okay, so let's go back to here, the code base that we were working on, and I'll demonstrate the synchronizing, the pushing and pulling. Okay, so we have made these changes, right? We have that one file, and again, let's go look at the repository. So currently, the state of the cloud repository is that we have this test file text and the Python script, but our local repository is ahead in that we only have one file now because we referred it. So the way that we do that synchronization is this button here. So if you click this button, it's going to synchronize. And then if we go to the website, you can now see that everything's synchronized. And then I guess I don't have it now, but if other people made some changes and your local repository was behind, then if you click this, then you should see that there are some, that it'll say that your local repository is behind, and you can do a fetch and pull. Okay, so now we can talk about branching. Let's see, how am I doing in time? All right. So now I'm getting into aspects of GitHub that I guess relative to everything that I've been talking about is on a little bit more on the intermediate side of things. And so the first thing that I'll be talking about is branching. Branching is a very strong aspect or feature of GitHub in that it allows for, it's a foundation for either a single person to be able to develop different features of a code repository in an isolated, controlled manner. And it also facilitates development of single features in an isolated manner if other people were collaborating on your repository. So let me explain how that kind of works. So let's say this is the commit timeline. So time moves this way. And this is your, what's called the master or the main branch. So that's what you are all working on. It's by default, you're gonna have a single branch when you make a GitHub repository. And let's say you have these 4 files, and that maybe file 1 and 3 serve a singular kind of goal. Let's say maybe those files are important for taking the average across frames for a data set. And then file 2 and 4 serve a different purpose, but kind of related because they're in the same repository. Here, maybe those files are trying to do some thresholding, like to get rid of baseline noise. So branching is a nice and dynamic feature in that what you can do is create another branch, and that branch is basically a copy of what you have in master. So it'll duplicate all those files, and then you can develop in that specific branch. You can edit any of the code in there. But in this specific example, let's say that this particular branch you named feature 1. So you're only editing the files related to image averaging. And so this is a hopefully I can illustrate to you that this is a strong kind of feature, because let's say that if you did this all on the master branch, where you're editing everything at the same time, maybe if you found a bug, or if a bug arose in your file 1 and 3, you might not be sure that that bug arose from edits that you made in file 1 and 3, or if maybe you, for some reason, file 2 and 3 were somewhat interacting with those other files, that those edits might have created the bug. So in the branching kind of architecture, it facilitates a controlled and isolated environment for developing specific functionalities in your code. Other kind of reasons for branching is if like one person in your team is working on feature 1 and another person was working on feature 2, they could each individually make separate branches so that they wouldn't be stepping on each other's toes. There are also other reasons, but those are the main reasons, I think. So let's go into how to create branches. I think this will do it here. Oh gosh. Okay. So going back to our GitHub desktop, that's creating a branch is what this tab is for. You can click this, and this will list all the branches that we have. Right now, there's only a main or master. I think older versions are called master. And so what you can do is click this button, and what it'll do is it'll make a new branch coming off of your current branch. So I'll call this feature. And so now, going to that feature will basically update all the files in your local directory. And any changes that you make will not be reflected in this main branch. So let me illustrate that for you. So let's do import numpy SMP. And then I'll commit that. And so if I go back to the main branch, you can see that, well, can't really see because it's only one file, but, or immediately you can't see. But if I go into this file, you can now see that there's nothing in there as it was before we made any changes in that branch. So this kind of brings me to the next important set of topics, which is GitHub collaboration. And that is, let's see, kind of running low on time, so maybe I'll speed through this a little bit. So we just made that branch, right? And one thing that we could want to do is or the ultimate goal is to take that branch and merge it back to either the main or the master branch, or if you're trying to collaborate with somebody else or make changes to another repository that's owned by somebody else, we're going to want to merge those changes in that branch to that other repository. So I'll demonstrate that here. And I think here, I was planning on having people follow along, but might not have time. So what I'm gonna do is, remember that this, I'll try to kind of orient you, but in this team viewer view, the computer that I'm on here, this is what we'll call the collaborator. And as a collaborator, what I can do is go to a certain, let's say we want to make changes to and collaborate on someone else's repository. So this one is a repository that I've made from my primary GitHub account. And what I'd want to do to initiate that collaboration is to fork that repository. So I'd click this button. I've already clicked it. And that's essentially allows us to make a copy. It's similar to clone, but in contrast to clone, a forked repository allows you to make collaborations and make changes, request changes to the original repository. And so again, that's kind of the way that we can bring that repository to our local architecture is similar to just cloning, or making a new repository. You would go to clone repository, and then the forked repository is here. Oh. I think I already have that one. Let me delete this. It's because I was testing it earlier. So this is the repository that I forked, and I can clone it now. So now this is my own version of that repository that is owned by somebody else. You want to click continue here because you do want to contribute to this this one, the repository that's owned by somebody else. And let's say I want to make a new branch that is develop feature 2. And then let's make some changes. So these are already some files that I added. Let's see, collaborator. I'm just gonna type in some random stuff. Collaborator is making more changes. So then what I would do is make the commit. Feature 2. And obviously publish the branch so that it can go to the cloud. So now you can see this button called pull request. And so that basically is a way for me as the collaborator to tell the original repository owner that, hey, I want you to review the changes that I've made. So you can here request that the owner reviews it. And you can say elaborate if you want, but then when you click this button here, then it is telling, the action will be to merge the contents of this developed feature to the original repository's main branch. Okay, so that's all you need to do as the collaborator. So I'm going to move now to my main computer and go to the owner. So if I go to the owner's GitHub repository, I can now see pull requests, and you can see now that, hey, somebody wants you to review. So here you can see some of the details of the request to merge those changes to your repository. And then here are some more details of the hoops, I guess, you need to go through in order to successfully merge those changes. The good thing here is that there's no conflicts, because on the main branch of the original repository, there weren't any conflicting texts. Here in this panel, you can actually see what changes were made, right? And so you can kind of test that, take a look broadly, and then running really long time. One last thing I think I want to show is that Adam asked about this before, and that what if you want as the owner to be able to test those changes out. So in the GitHub desktop of the owner of the repository, you can go to pull requests and then click that, and now you're in the all the files in your local repository reflect that pull requests changes. And then finally, you can click merge pull requests, and that will essentially merge everything together. So I'll end it there. Sorry, went a little bit over. I can take questions still, and I think for Adam, I'll show you how it looks when there's conflicts in here and how to resolve that. But I can take some quick questions, and if people need to leave, then they can. Do you want me to show you how? Oh, Barb, do you have anything?
Well, I think I got lost, but maybe I'll just rewatch the video.
Oh,
But
yeah.
I think I tried to add, I forked your NAPE computing seminar thing onto my GitHub, and I tried to add a text file that said boop. And then I tried to pull it to you, I guess. And
Okay, cool. Yeah, so
but
then,
I don't think it's showing up.
so which one? Not this
Oh
one,
no,
right?
it wasn't there. It was
Maybe
just
it's
NAPE.
the one that I made originally.
Yeah.
Let's see if I see the pull request. Oh. Oh no, this is
No.
no.
Oh, but it was to Zhou. I don't think I think I went to, I don't know who.
Is it this one? NAPE computing seminar. There you go.
Yeah, there we go.
Yeah,
Okay.
nice. So we're collaborating now.
Okay. Okay.
So, yeah.
thanks.
That's cool that it worked out for you, Barb.
Oh, okay. Great.
So maybe this is actually a good way to show how to resolve conflicts. So maybe hopefully this can work here. So what I'm going to do is go into there and actually make my own. Oh, hold on, I need to make sure that I'm in the right branch. So I think you're trying to merge it to main, right? So yeah, I'm just going to this and then just going to the main because I think that here you are trying to, yeah, merge your main to my main. So what I'm going to do is make my own boop file. And then have not boop. And so I think what should happen is if I commit this conflicts with pull request, I push to origin. So remember, that's to synchronize everything locally to the remote repository. And I go to pull requests again. So this, yeah, okay, great. So remember before this was green. It said, hey, you're able to merge. But now it's detecting some conflicts. So there are a few ways to, I guess, resolve these conflicts. And admittedly, I haven't really needed to do too much conflict resolution because, I mean, I'm like working with the people that that are contributing to my repository. But the way that I kind of have tested out is basically go back here. You can do use a web editor to resolve the conflicts. So again, here, this is what I was talking about, Adam, where it basically splits up the changes that were made from the, I guess, the person that was doing the pull request, and then here are the conflicting lines that are currently on the original repository. And so in order to resolve this, let's say that I'm fine with both of these. I can just delete these kind of added markers and then say mark as resolved and then commit merge. And then that'll kick us back to here and it'll check for compatibility. Now it says it's fine. Something cool that that you can also do is, I mean, we've already finished the merge, but let's say that I wasn't happy with things. I could be like, hey, Barb, I don't want you. I think you should do not boop. And then you can do that, and that will you can actually see that suggestion, and then if everything's fine, then I can say commit changes here, and that should be reflected in the final committed result. So if I do more merge pull request, confirm merge. Yeah, so it says merge now, and now if we go to the GitHub desktop, if I fetch origin, you can see now that there's a bunch of things that happened on GitHub, the remote repository that I could pull in, and then that history is now here, right? And then it should all show up in our, yeah, there we go. Well, so there's no regular boops. Does that answer some of your questions? I mean, this is a very like slimmed down version of how it works. I think it could get a little bit more complicated, but hopefully that's a good foundation.
Yeah, definitely. Thanks for going through all of this. At the start of the talk, you're saying that with the working through the command line gives you like a greater amount of, you say, flexibility and power.
Mhm.
What sorts of things can you do in the command line that you can't do through the GitHub app?
Yeah, actually, this kind of touches on the issue that you brought up, and I think I actually need to amend what I said, because your original question was if you had some changes. Yeah, okay. Yeah, I think I have to amend what I said. So if you have some changes, you made some commits, and you realized that the remote repository was ahead, and you want to bring in those remote repository commits to your local one. What I found to be quite cumbersome in GitHub, the desktop version, it's not super straightforward to bring those edits in. And the act of doing so really makes a messy kind of history. Whereas in some of the testing that I was doing, this was actually, I learned a bunch of this from my blood brother, who's like an actual computer scientist. And that process in like the command line is just simply like a one-liner that really cleanly takes all those new commits and adds them before your the existing commits that you have on your local repository.
And once you've done it with the command line, is that history then reflected within the application?
Yeah,
Or,
this
okay.
should as well. Yeah. Yeah, I think what I've done before is kind of go back and forth, and all those changes can be seen here. So I think maybe a hybrid version is nice, because you don't get this cool or this really intuitive file differences view in the command line, obviously. But I think for like kind of new users, I wouldn't be so focused and bogged down by like the branching and everything. I think the just a simple version control of working with the commits is a good place to start. Okay. With that, I think we can finish. Thanks for everyone for joining. And I'll see you. Hope you all have a good weekend, and see you next time.
Thanks, Charles.